And I probably have videos up from previous years, but I'm just going to do this because I don't know if I've got a video of this problem. So if s is your position, then what's your velocity? The derivative of that, right? And you're going to probably be given a velocity and maybe find acceleration and a position. In fact, the problem we're going to do on 2008 does it all, does both of them. And actually, part D is easier than part A. And so what's the acceleration? The derivative of the velocity with respect to time, which is the second derivative of the position. Have you done the bubbling?
Yeah.
Okay. So how do you know if a particle is moving to the right? So the particle, or up or down, is moving to the right. What's true about the velocity? It's positive. If it's moving to the left, the velocity is negative. How do you know if it's speeding up or slowing down? Okay, speeding up. B and A have the same signs. And if it's slowing down, B and A will have opposite signs. How would you, if you were given the velocity, find your position? To find your position is the integral of the velocity. Okay, now remember, that's assigned area, so that's going to actually give you your displacement. How would you find your distance then? You have to do it in pieces. So if I integrate the absolute value of the velocity, dt, that would actually give me the actual displacement. That would have to be a calculator question, or no, this one's not a calculator. They can give you the areas. They'd have to give you something like that. But to have you integrate the absolute value of some function, they wouldn't ask you to do that. I think that's all there is I can think of. Yes? Right, if you could know how to break it up. You have to, if it's a non-calculator problem, you're going to have to break it up because you don't know how to integrate the absolute value. So it would have to be a quadratic at worst. Then you just put it in your calculator. So let's look at 2008 number 4. And the first thing you should do is when you do this is look at the picture and see what you notice about it. What are you given? Because the thing is, what happens is you jump in too fast, and then you don't realize that this is not the position. This is the what? This is the velocity graph. Not the position. So, look it over before you jump into the problem, and maybe read some of the words. There are a lot of words here. It's gotten wordier as the years have gone by. And so that's your velocity. And so I'm looking at my graph. My velocity appears to be 0 here, here, and here. Okay? And the position then would be adding up the area under the curve, because that's when the integral is. Let's read the problem. Particle moves along the x-axis, so they're going to call it x of t rather than s of t. So its velocity time t is given by a differentiable function whose graph is shown above. They don't tell you what it is. They make this really clear. The velocity is 0. So that means you're stopped there at when t is equal to 0, t is equal to 3, and t is equal to 5. And the graph has horizontal tangents at t equals 1 and t equals 4. Why did they tell me that? That's the maximum distance. Sorry, that's the maximum velocity, not distance. Right? Or actually, it's minimum, because it's a negative sign. And this is the maximum velocity. So you're going the fastest to the right, and you're really going to the fastest but to the left. I know it contradicts, but whatever, that's what it is. The areas of the regions bounded by the t-axis in the graph on intervals from 0 to 3. The first one is 8, but you know what? The area is 8. What's the integral? So I wrote negative 8 in the last class and helped me to remember it's negative if I want to do an integral. And then from 3 to 5, it's 3. And from 5 to 6, it's going to be 2, but it's negative because it's below there. The integral is negative. So you read the questions carefully, because I've seen this on multiple choice. They'll say the areas are 8, 3, and 2, or sometimes they'll put the negatives in. Just read it carefully so that you interpret the right thing out of the problem. And really, A and B are the hardest questions. Let me move some things here. D is the easiest. Okay, it says find both the time and the position of the particle, and the particle is furthest to the left. I want to go as far as possible to the left. So think about what's happening. You're starting at your starting position. Where's your starting position now? Did I forget to read that part? What is it? If t equals 0, the particle is at x equals negative 2. You're not starting at the origin. Yes. You can do it that way. I'm going to do it with fundamental theorem instead, because it works. Okay, so you're starting at negative 2, and then what's happening? Your velocity is negative, so you're moving left. And as you move left, you're getting further and further away from the origin. Does that make sense? And you keep going left until you get where? So you get a point for that. T is equal to 3. It stops at 3. So what it's doing is it starts here at negative 2. It's moving to the left, and at about 1 second, it's going to be moving as fast as it could be. So just bear with me. So it's moving to the left, and it's going to speed up, and then it's going to start slowing down, and then it's going to stop. It's going to turn around, and then it's going to go this way. And it'll be going really fast by the time it gets to 4. And it's going to have to slow down again, because it has to stop at 5. Those of you who drive cars, you know about these things. The stoplight, you go slow. You get 55 miles per hour, and then there's another stoplight. So you put the brakes on, you start slowing down. Okay. And it says, find both the time and position. So I found the time. I need the position of the particle. Well, you can do it with just a plain integral, or you can do it with the fundamental theorem. Well, I don't even know how to do it with plain integral. The position, x of t, is equal to the integral from t1 to t2 of v dt. So if I want to find the position at 3, I'm going to integrate from 0, that's my starting position, to 3 of v dt. Sorry, I don't want the parentheses there. v dt. And so that's going to equal my position at 3 minus my initial in the beginning. Remember, that's the change in your position. It's your total change. Total change theorem, fundamental theorem of calculus, same thing. If I solve for x of 3, it's equal to x of 0 plus the integral from 0 to 3 of v dt. So x of 0 is what? Negative 2? And then, what's the integral of the velocity from 0 to 3? It's negative 8. I could see very easily how you could put in a positive 8. So you're at negative 10. You know what? I'm going to put that on my graph, because I know what the next question is. So I might as well put it there. So this is x equal to negative 10. Are there any other places where I'd have to look? Is the velocity negative someplace else? Yeah, t equals what? 6. You have to consider that. Some of you may be looking at it saying, well, I know it's not further to the left at negative 6. But you don't really know unless you do the calculations. Now, using this as a model, here's my fundamental theorem. Matt says, why don't I just take negative 2 plus that integral? You're right, Ken, you may do that. So I'm going to find x of 6 is going to be equal to my initial position plus the integral from 0 to 6 of v of t dt. You lost points, yes. You have to include that. Now, how much do you have to write? Is this enough right here, the negative 2 and negative 8? I would be careful with it. I would write it in the calculus style and then do that, because then that shows for sure that you are thinking correctly. If you do this, that could have been just blind luck, and it could be. Okay, so this is going to be at negative 2 plus, and then I have to do all the area from 0 to 6. Well, that's a negative 8, a plus 3, and a minus 2. So if I add all that together, I'm going to get, well, it's negative 5 minus 2. Did I do it right? What is the answer? Is that negative 9? No, that's negative 9. That's right. So this is negative 9. Look right here. X equals negative 9. Now let's look at how we got that scored. There it is. Lot of writing. First getting 3 as your candidate, but also looking at the 6 as a candidate. Basically, that's what that's saying. And then 1 point for your conclusion. But I really kind of think, you know, I didn't grade this year, but I really kind of think they were looking for this too. Part of the justifying. We're still with the same chief reader. Now, this was a different chief reader. Today's, the chief reader I worked for, I would say you have to put that red circle in there. Won't hurt you, but if you don't do it and you needed it, it will hurt you. They were really picky last year about justifying your response. Now that one wasn't really too bad. D is way easier. Make sure you put your answers in the appropriate place. Although they will back read, but they won't forward read. Okay, the next question is probably the toughest one because it involves a theorem that we haven't done much with. At how many values of t on that interval is the particle at x equals negative 8? Well, when I go from, oh, I'm out of colors. When I go from negative 2 to negative 10, didn't it go through negative 8? It didn't just jump, did it? No, because this is a continuous function. And then, so that's one place. What else do I need to know to answer the question? I need to know one other thing. Otherwise, I can't answer the question. Here's x equals negative 9. But what happens here? It goes to the right and it comes back. I need to know where it is there to know that. So I need to find x of 5. Well, x of 5 is x of 0 plus the integral from 0 to 5. Sorry, it's kind of messy. So it's negative 2, and what's the integral from 0 to 5? Plus, what's the integral from here to here? Negative 8 plus 3, right? And what is that? Negative 7. I didn't lift my finger up before. Negative 7. There. So now let's look at this again. From negative 2 to negative 10, it does go through negative 8. What about negative 10 to negative 7? Does it go through negative 8? Yes. And negative 7 to negative 9, does it go through negative 8? Yes. And you would have to talk about all this stuff that I verbally talked about. So it would be 3 times. Yes, you have to say on this interval. I'll show you the square root. I'll show you what they're looking for. I wouldn't want to read this one, to tell you the truth. Does anybody know why I know it really did go through negative 8 3 times? There's a theorem for it. Mean value theorem is close, but it isn't that intermediate value theorem. And maybe when you go in the lab, maybe I'll go and look it up and look at the commentary on this to see what happened with this problem. And right now, if you're in the middle of the test and you're going, I don't know how to do that, are you going to look at the next 2 questions? Probably not. Don't do that. The next 2 questions are easier. So let's see how they graded this. I don't have all my answers written out, by the way, because I don't want to take the time to do it. There it is. Okay, so you got a point for all these guys. So that's nice. If you didn't do the 5, you don't get the point. I'm pretty sure of that. Description of your motion. I have 2 out of 3 because I said intermediate value theorem and I figured out what the answer was. But unless I wrote out what I talked about, and what did we talk about? the particle moves continuously, don't worry about the monotonicity, it's not important. Well, I'm going to say it's not important, but they aren't going to look for that because nobody's going to use that word. And then they said, when time is 0, it starts at -2. When time is 3, it gets to -10. You need to talk about that. It's like I talked about it. But you're going to have to write it, which is unfortunate. And then x of 3 is -10, to x of 5 is -7. You could write it this way. It's a little more succinct. And then x of 5 is -7, to x of 6 is -9. And that's your 1 point for your description of your motion. There are a lot of ways to say it. Yes. X of 5 was because of the fundamental theorem of calculus. Sorry, go back. And I'm going to get to a better pen. If I integrate from 0 to 5 of v dt, I will get x of 5 minus x of 0. See how we've seen the fundamental theorem again and again and again. Here it is. This is 2. So x of 5, oh, sorry, -2. -2 plus the integral from 0 to 5. And to find the integral, it's just the area under the curve, so you just have to add up the areas. I kind of like the problem. Once I've actually looked at it, it's not that hard. I just have to do -8 plus 3. I don't have to know geometry. They could give you this as a triangle and maybe a trapezoid, and then have you calculate that area, make it a little bit harder. And there have been problems like this. You will see something like this on the exam. It's guaranteed. You will see a problem similar to this. If you look at every single year, there's something like this. Okay, and now to do the next part, on what interval is the speed of the particle increasing or decreasing? So if the speed is increasing, I said this wrong last time. If the speed of the particle is increasing, it's speeding up, right? If the speed of the particle is decreasing, it's slowing down. Well, if you know that, then this is hard. This is easy. So between 2 and 3, what's your velocity? Right in here, what's your velocity? Positive or negative? Positive. No, the velocity is not positive. Velocity is negative, right? Velocity is less than 0. What's the acceleration? That's positive, yes. And so therefore it's what? It's slowing down, or to put it in the same words that they use, the speed is decreasing. There's your justification. Got to read though. Sometimes read something like this, it's not the speeding up, slowing down. So read the question carefully. Let's see what the scoring rubric says. But that's the easy one. I know we can get that. Yeah, I'm really curious to see what the analysis was. The speed is decreasing because the velocity is negative, and instead of saying the acceleration is positive, but the velocity is increasing. You can say it either way. Same thing. 1 point. Ooh, not very big. If you miss part of it, you don't get your 1 point. And then the last question is, oh, don't do that. During what intervals is the acceleration of the particle negative? Where is acceleration negative? 0 to 1 and 4 to 6. That's the easy one. 0 to 1 and 4 to 6. And they're going to say because the velocity is decreasing. I wouldn't mind, I don't know, we can get by with the slope of the tangent line is negative. And that's all they're asking for. So really, it's not that bad a problem. Okay? That's what we're doing tonight. We'll be working on those kinds of problems. Usually Mrs. Hersman goes to the board, works problems. If I'm not too busy, I'm down here. The BC kids kind of come hit or miss, come down and work on problems just one-on-one with me if you want. A lot of times that's what we do.